All right, lesson 3. We're going to look at vector addition in 2 dimensions where we have 2 or more vectors to add together to get a resultant vector. So in this case, as I've stated here, the complete vector addition is shown for you. But typically for a problem, you would be given individually the vectors A, the vector B, the vector C, and you would have to generate the diagram shown here. And to remind you of the tip to tail, it will always be done the same way. You take the first vector and redraw it as is from the origin. So 0, 0, our origin. Redraw vector A as is. Put the tail of vector B to the tip of vector A. So I think of it as stacking arrows. But we're not going to change the orientation when we do our vector addition tip to tail. You just pick them up and pin them down. They then would have pinned down vector C to vector B, and that finishes my vector addition. Now to draw in the resultant, I go from the origin to where my vector addition ended, and again, biggest mistake I see from students is they don't draw vectors, they just draw lines, no arrows. So do not be one of those people that doesn't put in arrows. So your resultant vector is an arrow going from 0, 0 to wherever the vector addition ended. Now, if I did all of this very carefully with a ruler, and if I had to, a protractor, but these numbers were just gotten, the 4.5 centimeters, the 2.7, and the 7.7 were just from taking out my ruler and measuring those vectors. So if I just measured those vectors, we started by going over positive 4.5, up 2.7, and then to the left, that's what the negative means, to the left 7.7. We come to the end, and then if I took my ruler and measured this arrow, I got 4.2 centimeters. And if I measured the angle, I got 42 degrees. Well, let's see if that answer would correspond to doing our vector addition algebraically. So this would be the ruler and protractor way. And algebraically, I could just take the vector A and write it in Cartesian or component form. So we only have the 4.5 in the x direction. There was no movement in the y direction. For B, there was only movement up in the y direction, no movement in the x direction. And for C, there was backwards movement in the x direction and no movement in the y direction. So now I'm kind of like an accountant, keeping my ledger, my columns all neat and orderly. I can add and subtract the x's and add and subtract the y's to get my resultant vector, negative 3.2 and positive 2.7. So my resultant vector is backwards 3.2, up 2.7, and if I use Pythagorean theorem on that, I would get 4.129, and if I use inverse tangent for theta, I get 40.5 degrees, and if you compare our numbers here and our angles, they are pretty close. Now, your ruler and protractor is going to be less precise, so, those numbers, typically you would use a graphical method when you just want to get an idea of the answer. If you really want to know the numerical answer precisely, you would actually calculate it mathematically and algebraically. However, theoretically, if you were a perfectionist and drew everything out perfectly, no mistakes whatsoever, those numbers would match up perfectly. It will depend for you as to what the question is asking you to do. Is it asking you to kind of use your ruler and protractor and get an answer that's close, or is the question asking you to calculate it mathematically? You do not have to be a mind reader. You will not have to guess what they are asking you to do. Okay, next page. Let me erase that. Okay, on this page of notes, what we are looking at is if you were given 3 vectors, so you were given the information that vector A is 3.3 centimeters at angle 40 degrees shown, so that's this angle down here, and vector B is 4.6 and at 56, and vector C is 7.2 at 17. So you're just given, that's the question. That's part of the question. You're just given the vector A, B, and C. So the first thing I would like you to do when you're given multiple vectors and you're asked to add and subtract them is to immediately put each of the vectors in terms of their component vectors. So notice the vector B is made up of a vector B sub x over to the right, so my arrow shows it over to the right, and the angle is the length of it is 4.6 cosine 56, and then a vector B sub y up, and I used sine since it's opposite over hypotenuse, and the hypotenuse is 4.6. So 4.6 sine 56 to get I can calculate that out to get the value. We'll do that in a moment. But having these component vectors allows me then to get my resultant simply by doing my algebraic method of keeping my columns of x, columns of y all in line and getting my answer like we did here. So I want you to automatically think of getting everything in terms of their component vectors. I do the same thing for vector A, and I will do the same thing for vector C. I'll show that below to get the resultant algebraically. So if I was going to use my ruler and protractor to try and estimate the answer, what I would do is use my tip-to-tail method, and I would take the vector A. Let me see what the vector A is here, and redraw it as is from the origin. So the first vector of a vector addition, you just redraw. That's 0th step. You just redraw the vector. Now what I do when I'm working with vectors that aren't on the x and y axis, I'll just hand sketch in a little y-axis and a little x-axis at the end of the vector to kind of help me keep things straightened out. So notice then to do my vector addition with vector B, I'm going to pick up vector B and pin it to vector A without changing the orientation, and that's vector A plus vector B. Now if that was the only part of my vector addition, I would go from 0, 0 to the end of that vector and draw on my resultant vector. But I have a vector C to add on. So what I'm going to do here is, again, kind of help me keep my angles and my page lined up. I'm going to put on just a little x and y axis there. I'm going to pick up the vector C exactly as it is over here, which is 7.2 centimeters long, and the little angle in here is 17 degrees. And then I'm going to get to the very end of my vector addition, vector A plus vector B plus vector C. I can now put in my resultant vector. I can take out my ruler and measure the 4.9 centimeters. I can take out my protractor and measure the 63 degrees. And I have a polar form of the answer. Really an estimate using my ruler and protractor, or if I'm a perfectionist, theoretically it should be perfect. Well, let's compare it to our algebraic or our mathematical answer. Well, here, what we're going to do is take our calculations for the vectors A, B, and C in component form and keep all of our x's lined up, all of our y's lined up, and get our resultant vector in component form. And now I'm going to go back and use Pythagorean theorem to calculate the resultant and compare it to what I did with my ruler and protractor. Notice, now I do have a little bit bigger discrepancy. I have 4.2 centimeters, 4.9 centimeters, and I have 63 degrees, and I calculated 64.6 degrees. Now, again, which one you are going to use is going to depend on what the question is asking you to do. If for a quiz or a test, we're asking you to use the ruler and protractor, I will know that I am getting an estimate for these values, and you will be marked accordingly in terms of your grade. You'll be very lenient in terms of I'll look at your diagrams to make sure everything just looks proper, and as long as you reasonably need it all, you will get full credit. So this is going to be the first part of our lesson. I'm going to stop it here, and we can go over questions or talk about this.